I found this guy's channel, and he's got a bunch of interesting stuff. Like, I saw this, why black holes could delete the universe. It seems kind of neat. So I'm going to watch another space video.
Are the most powerful things in the universe. Strong enough to rip whole star.
Oh, Swahili Sack, thanks for the $2 and the... Thanks for the $3.50. Appreciate it, my friend.
Into atom-sized pieces. While this is scary enough, they have an even more powerful and dark property. They might delete the universe itself.
See, the cartoons make this less frightening. Kurzgesagt, that's like a German name, I trust
in
them.
a nutshell.
They know science.
A black hole appears when an extraordinary amount of matter is concentrated in a tiny space. At their center, gravity is almost infinitely strong, and whatever gets too close is ripped into its elementary particles. Not even light can escape black holes, and so we perceive them as spheres of blackness. If you were to fall into a black hole, nothing bad would happen until well after you crossed its outer border, the event horizon. You can imagine this as swimming in a river that
Okay,
ends
I've always
in an
wondered
enormous
this. Come on,
waterfall.
break this down for me, man. What
As you
happens?
float along, imperceptibly, the stream gets faster and faster, even if you can't see the waterfall yet. You could swim to safety until, without even noticing it, you cross the point of no return. No matter how fast you try to swim now, the stream will pull you towards certain death. Nothing can escape a black hole waterfall once it gets too close. This border completely separates black holes from the rest of the universe. We can't access them unless we're willing to never return. So there's no way of telling what's really going on inside black holes, but we have a few ideas about what's going on right at their very edges. Black holes radiate their mass away, like a hot pot on a stove losing its water as steam. This is called Hawking radiation. Black holes constantly lose an extremely tiny amount of their mass, a process that's unbelievably slow. It will take a black hole with the mass of our sun 10,000 billion years to lose 0.0000001% of its mass. This is happening constantly and unstoppably.
That is very
as it goes
slow.
on, it speeds up more and more. In the far, far future, when the last star in the universe has been dead for trillions of years, black holes will become tinier and tinier until they evaporate and disappear, leaving behind just a bit of radiation. But this is a problem, because in the process of disappearing, black holes might delete something fundamental: information. 2. What is information? Information is nothing tangible. It's typically understood as a property of the arrangement of particles. What does this mean? Imagine a bunch of carbon atoms. Arrange them in a certain way and you get coal.
Thank you, Amish
Arrange
Donkey.
them in a different way and you get a diamond.
Oh, thank you, Matt Woodworth, for the 3 gifted
The
subs. I
atoms are
really
the same.
appreciate it, my big dick
What
friend.
changes is the information.
Thank you.
If we make this more complex and add in a few more atoms, we get a banana. Change the arrangement of the atoms and we get a squirrel. The basic building blocks of everything in the universe are the same and don't care if they're part of a bird or a rock or a cup of coffee. Without information, everything in the universe would be the same. According to the theory of quantum mechanics, information is indestructible. It might change shape, but it can never be lost. For example, if you burn a piece of paper, you get ash. That ash will never become paper again. But if you were able to carefully collect every single carbon atom in the ash and measured the exact properties of the smoke and heat radiating from the fire, you could, in theory, reconstruct the paper. The information of the paper is still in
wild.
the universe. It's not lost, it's just hard to read. If you could somehow measure every single atom and particle and wave of radiation in the universe, you could see and track every bit of information there is. Hypothetically, you could see the entire history of the universe right back to the Big Bang. And here, black holes trip us up. Information tells us how things are different from each other and what used to be what. Black holes do the opposite. They take different things and make them the same. They destroy information. This creates the information paradox, and this is a serious problem. The information paradox. It's fundamental for all our laws of physics that information can never be lost. Existing, not existing, without information, everything is relative. When it comes to our understanding of reality, we need absolutes. How could we solve this paradox? There are a few possibilities. 1. Information is lost, irretrievably and forever. This means we have to nix all our laws of physics, throwing out a lot of stuff that's worked very well so far and start from scratch. What those new laws of physics would look like, or what that means for us, nobody knows. This is a little frightening, but also kind of exciting. 2. Information is hidden. Maybe a little part of the black hole splits off and forms a baby universe.
Yeah, we really don't know
the
anything.
Information would be transferred into this new, weird place where we could never observe or interact with it, but technically it would not be lost. It's like having a broken hard drive with all your family photos that you could never access. Sure, it's nice that they've not been deleted, but also not very helpful. Or maybe black holes don't disappear completely after the end of their life cycles, but a little piece is left, an information diamond. Like a clown car filled with an infinite amount of information clowns.
That's a
But there's
terrible
third option.
comparison. That's not helpful.
Information is safe after all, not lost or hidden. Perhaps we've just been
Matt
looking at this whole
Woodworth
thing
with
the
3
wrong way.
more gifted subs. Thank
We
you so
know that
much,
black
Matt. That's
holes
6
trap
on the day.
information and might
Big dick
delete it
move.
later, but we never thought about what they do with it in the meantime. Where do black holes store their information?
Yeah, honestly, the writer for this, who was like, how will we help him understand it? Well, think of them as information clowns that are in an infinite form of clown cars. It's like, shit, but that's so not helpful. I know less than I did before that comparison.
Cosmic housekeeping. Let's create a black hole with dirty laundry. First, we fill up a room with laundry baskets. The more laundry you want to store, the more baskets you put in the room. But at some point, every single basket is full and the room is completely stacked. Not a single extra sock fits in. The room is at maximum capacity. But if we still squeeze the sock in with a lot of energy and violence, the room collapses in on itself and forms a black hole. But the capacity of the room itself has not changed. Fitting in more stuff or information is still impossible. So what happens if we throw more laundry into it? The room itself gets a little bit bigger to make space for the new information. It turns out a black hole grows its surface by a tiny pixel for each bit of information we throw into it. In a nutshell, more information means more surface area. The information gets painted on the surface, similar to what happens when we throw a stone into a pond. After the stone sinks to the bottom, we can't see it anymore, but we can tell that something went in from the ripples on the surface of the pond. Even the smallest black hole can store more information on its surface than all the data ever produced in human history. They do this by storing information in a type of pixel that is unbelievably tiny. Black holes are the ultimate hard drive. This is a bit like taking a paperback and turning
Is
it
it
into
really,
an
though?
ebook. Two things that look completely different, but their content is the same. It's just encoded and memorized in another way. Black holes swallowing stars and planets is a bit like transferring a whole library onto an e-reader. This solution is called the holographic principle, but if it's correct, then everything we thought we knew about the universe is wrong. The universe is a hologram. If information is actually stored on the boundary of a black hole, the Hawking radiation has a chance of learning about the information encoded there and can carry it away. So, information is not lost when black holes fade away, and we do not need to redo physics. The information paradox is resolved. But we still have to change our understanding of reality in a fundamental way. If everything that falls into the black hole is stored on its event horizon, that basically means that three-dimensional stuff is encoded on a flat surface. We have a name for this, a hologram. A hologram is like a 3D photo, a flat piece of plastic that encodes a three-dimensional image. A black hole is like a hologram because everything inside it is encoded on its event horizon. A person inside a black hole would experience their usual three-dimensional life. But for us on the outside, they are flattened images on the surface of the black hole. The consequence of this is counterintuitive, but stay with us for a moment. Black holes are very extreme objects, but they're still bound to the same rules as everything else. So if this crazy duality between 2D and 3D works for black holes, then it might work for the...
I thought black holes weren't held to the same rules, and that's why a lot of that shit from the last video happened. No? No, I don't know, whatever.
Whole universe and you in it. Since a person inside a black hole would not realize that they're encoded on a flat surface, we might share the same fate. You really might be stretched over a flat screen at the end of the universe. The science behind this is complicated and really weird, with toy universes to play with, string theory, and a lot of maths. We'll talk about this more in another video. Regardless of what the true nature of the universe really is, we just know that it's strange and complicated, and we have to do a lot more physics to understand it. But black holes might be key to understanding the nature of reality itself. This video was supported by the Swiss National Science Foundation and realized with the scientific advice of Alessandro Sfondri.
I don't know. This could just be big science trying to scam us the way they did with vaccines and medicine. Bunch of mumbo jumbo, if you ask me. I did want to watch this nuke one. Bunch of fucking mumbo jumbo. Watch the Great Filter. I'll look that up. What is it? Is this Black Science Man? The nuke one sucks? Oh, that's disappointing. What time is PKA? We always start recording at 6 p.m. Central. 7 Eastern. Well, I thought that one of the nuke ones seemed cool. Nuke one is great. Yeah, I'm watching Nuka City, and if Nuka City is good, I want to upgrade to nuke everything at once. Because if I'm being honest, my knowledge on nukes leaves something to be desired. I would go so far as to say I'm somewhat of a novice when it comes to nuclear physics. And I'm not afraid to admit it. I'm humble enough to say that.
And with nuclear weapons in videos is fun. There's a visceral joy in blowing things up and a horrifying fascination with things like fireballs, shockwaves, and radiation. And while it does help put our destructive power in perspective, it's not the best way of understanding the real impact of a nuclear explosion. This isn't about silly stacks of TNT or about how bright an explosion is. Nuclear weapons are about you. So we've partnered with the Red Cross and Red Crescent movement to explore what would really happen if a nuclear weapon were detonated in a...
This is just an aside, but if there are... Oh, Squeaky Hamster, thank you so much for the sub. This is an aside, but if there are any really good videos about, like, comparing the size of bombs in the past, like, as they got more advanced, that would be a really cool video to watch. So tweet those at me if you know one of those that's really cool, because that sounds sick.
Major city today. Not nuclear war, just one explosion.
Watch the Vsauce one.
We begin our story in the middle of downtown in a major city. People are going to work, studying for exams, are lost in their thoughts and daily lives. Right here, a nuclear weapon is detonated and time freezes. The first phase of the explosion happens within less than a second. In a millisecond, a ball of plasma hotter than the sun appears and grows in a fireball to more than 2 kilometers across. Within this ball, everyone is just gone. Think of water dripped onto a very hot pan. A sizzle, and then there's nothing. Most buildings, cars, trees, tacky sculptures, and people, all evaporated.
That's wild.
First, the flash, an intense tsunami of light, washes over the city in an instant. If you happen to have your head pointed in the direction of the explosion, it renders you blind for a few hours.
Thank you, Susiana, for the sub. Really appreciate it.
Produces a thermal pulse, so energetic and hot that it just burns everything as far as 13 kilometers from the detonation site. What this means is that everything in an area of 500 square kilometers that is able to burn starts burning. Plastic, wood, fabric, hair, and skin. If you happen to be in reach of the thermal pulse, one moment you're on your way to work, the next moment you're on fire. Now the second phase
You
begins.
die so fast.
It happens in a few seconds. Most people will now first notice that something is wrong, but it's already too late for hundreds of thousands. The flash is followed by the shockwave. The heat and radiation of the fireball create a bubble of superheated and supercompressed air around it that's now expanding explosively, faster than the speed of sound, creating winds stronger than hurricanes and tornadoes. Human infrastructure is no match for its power. Most major buildings within a kilometer of the fireball are just ground up down to their base. Only steel-reinforced concrete is able to partially resist the pressure. In the surrounding parks where retirees feed the ducks, trees blackened and smoldering from the heat a second before snap like toothpicks. If you're outside, you get tossed away like a grain of dust in a tornado. The shockwave weakens as it travels outwards, but still, about 175 square kilometers of houses collapse like they're made of cards, trapping tens of thousands of people who didn't have any time to react. Gas stations explode and fires spread throughout the rubble. A mushroom cloud made from the remains of the fireball, dust and ash rises kilometers into the sky in the next few minutes and casts a dark shadow over the ruined
Inventing
city.
these things was a mistake.
This violently pulls in fresh air surrounding the city, destroying more buildings and providing an abundance of oxygen. It depends on the city what happens next. If there's enough fuel, fires may turn into a firestorm that burns the rubble, everybody trapped in it, and people trying to flee the devastation. Up to 21 kilometers from the explosion, people just like you rush to their windows to take pictures of the mushroom cloud, unaware that the shockwave is still coming at them, about to shatter their windows and create a blizzard of sharp glass. The third phase begins in the coming hours and days. We're used to the idea that help will come, no matter the disaster. This time is different. A nuclear explosion is like every natural disaster at once. There are hundreds of thousands.
The most, totally believable thing about this is how everyone with an Instagram account would just get shards of glass in their eyes from trying to take photos and shit for clout as this was happening. That's a guarantee. Very realistic take from this guy. So I'm trusting him.
Or millions of people with serious injuries, lacerations, broken bones, serious burns. In the next few minutes and hours, thousands more will die because of these injuries. Countless people are trapped in collapsed buildings like in earthquakes, or blinded by the flash, deaf from the blast wave, and unable to flee through streets impassable with rubble and debris. They're terrified, confused, and don't know what's happened to them or why. Most likely, many hospitals have been leveled along with all the other buildings, and most medical professionals are either dead or injured along with everyone else. The survivors lucky enough to have been in metro tunnels or standing in the right place to be unburned and unhurt won't have truly escaped harm yet. Depending on the type of weapon, where it explodes, and even the weather, an awful black rain can begin, with radioactive ash and dust descending on the city, covering everything and everyone. The invisible, malicious, silent horror of radiation takes its turn. Every breath carries poison to the lungs of the
Doctor,
survivors.
thank you for the $3.
Over the coming days,
Nervous about
the people
Taylor,
who
you nervous
receive
about
the highest
tomorrow?
doses
No.
of radiation exposure will die. There will be no help,
Not unless there's a
not
nuke.
for hours or maybe even days.
But nobody's nuking St. Louis,
Civilization
man.
doesn't operate when there is a total breakdown of infrastructure. Roads are blocked, train tracks warped, runways cluttered with rubble. No water, no electricity, no communication, no stores to replenish supplies from. Help from surrounding cities will have a hard time entering the disaster zone, and even if they can, the radioactive contamination will make it risky to get too close. After a nuclear attack, you're on your own. So, bit by bit, people emerge from the rubble. on
Slowpoke
foot,
Moses, thank you so
contaminated
much.
With radioactive fallout,
Thank you for subscribing.
carrying
I hope
what
you
little
never
they
die
may
of a
have
nuke.
left. They are slow, in pain, traumatized, and they all need food, water, and medical treatment fast.
Thank you, Big
And
Head
the damage
Society.
done by a nuclear weapon doesn't end when the fires burn out and the smoke clears. The hospitals in the neighboring cities are under-equipped for a disaster of this scale and overwhelmed with tens or hundreds of thousands of patients with serious injuries. In the weeks, months, and years to come, many of those who survived will succumb to cancers like leukemia. The reason no government wants you to think about all this is because there is no serious humanitarian response possible to a nuclear explosion. There's no way to really help the immediate victims of a nuclear attack. This is not a hurricane, wildfire, or earthquake, or nuclear accident. It is all of these things at once.
But it's got to be like a matter of time until we come up with some sort of robot suit that can do it, right? I mean, if we can make nukes, we can make a robot suit that can resist it to walk in there, right, and save people. But then they'll be all fucked up. They probably don't want to be saved. Yeah, a nuclear-powered robot suit. Well, I mean, everybody in the center part is fucked, but those little periphery people, like the old people and the kids playing at the park that got kind of burned up, you could probably save them a bit with robot suits. Right? Right?
But worse, no nation on Earth is prepared to deal with it. The world has changed in the past few years, with world leaders again explicitly and publicly threatening each other with nuclear weapons. Many experts think the danger of a nuclear strike is higher than it has been in decades. Governments tell their citizens that it's good that we have nuclear weapons, but it's bad when anyone else gets them. That it's somehow necessary to threaten others with mass destruction to keep us safe. But does this make you feel safe? It only takes a small group of people with power to go crazy or rogue, a small misstep or a simple misunderstanding to unleash a catastrophe of unimaginable proportions. Exploding stuff in videos is fun. Exploding things in real life, not so much. There is a solution though. Eliminating all nuclear weapons and vowing never to build them again. In 2017, almost 2/3 of all the world's countries supported by...
That is a hilarious solution. Like, imagine getting up in front of the entire world and being like, all right, the only way we can solve this, guys, is if everybody gets rid of all their weapons and we all get together and we pinky promise and then we kiss our hands together and say we're never going to do that ever again. It's like, what the fuck? Are you high? Of course that's not going to work. No one's going to get rid of it. There are countries that exist right now that won't even sign nuclear non-proliferation agreements. You think you're going to convince everybody to get rid of their shit?
Hundreds of civil society organizations and the International Red Cross and Red Crescent movement agreed to prohibit and eliminate nuclear weapons. It's not about who has nuclear weapons and who doesn't. The weapons themselves are the problem. They are deeply immoral and an existential threat to all of us. No matter what country you come from, no matter what political side you find yourself on, we need to demand that they disappear forever. This will not happen without pressure. If you want to be part of this pressure, there are things you personally can do too. Visit notonukes.org to...
Nah, nukes are tight, dude. I'm not going there. I do want to know what happens if we blow up every nuke at once. Everybody's always wondered this, right? What happens? YesToNukes.org. And the whole it's just some shitty mid-2000s style webpage with like GIFs in the background, a paneled GIF background, like a MySpace page. Auto plays music when you join, but it's like fucking like Rob Zombie amp up music, and it just shows all the cool bombs we've built over the years. That would get signatures.
Many of our viewers have asked us a very serious question. What if we made a big pile of bombs and exploded every nuclear weapon in the world all at once? Strangely enough, we couldn't find a good source to answer this question to our satisfaction. So, we gathered together a few scientists to calculate what would happen and find an answer to this extremely important scientific problem once and for all. Currently, there are 15,000 nuclear weapons on Earth.
That we know about.
The US and Russia both have around 7,000, while France, China, the UK, Pakistan, India, Israel and North Korea own around 1,000 between them. But how much destructive power is this really? Let's try to put these numbers into perspective.
Thank you, the government never lies.
On Earth, there are about 4,500 cities or urban areas with at least 100,000 inhabitants. Some are bigger than others, so we'll assume that on average we need 3 nuclear bombs to completely wipe out one city. This means we could destroy every single city on planet Earth with our nuclear arsenal, killing more than 3 billion people, roughly half of humanity, in an instant. And we'd still have 1,500 nuclear weapons left. Now that's what an expert would call overkill. So we can say with confidence that we have a lot of nuclear weapons and they can do a lot of damage. But what if we make a huge pile of all 15,000 bombs and pull the trigger? Let's drop our nuclear pile in the middle of the Amazon rainforest, just to show nature who's boss. Our warheads, piled haphazardly, fit into a small warehouse. A typical US warhead has the power of 200,000 tons of TNT. So 15,000
this is what I wanted
would be
to know.
the equivalent of 3 billion tons of TNT. For scale, this is enough to rebuild the whole island of Manhattan with every building and skyscraper using stacks of TNT.
Jesus
The
Christ.
closest thing we can compare to the energy gathered here is a volcano. One of the deadliest volcanic eruptions in recorded history took place in 1883 on the island of Krakatoa. The eruption was so powerful that 70% of the island and the surrounding archipelago was destroyed, killing tens of thousands of people. Its effects were felt around the world for days after the event. Our nuclear pile contains 15 times the energy of the Krakatoa volcanic eruption. So let's finally push the button. 3,
That's
2,
insane.
1. In a second, a fireball 50 kilometers across vaporizes everything in its way and creates a blast wave that flattens 3,000 square kilometers of forest. Every living thing within 250 kilometers will start to burn. The explosion will be heard literally around the world as the pressure wave circles the Earth tens of times over the next few weeks. Millions of tons of incinerated material are catapulted into the atmosphere. The mushroom cloud reaches the outer reaches of the stratosphere, pushing up against space itself. After things have calmed down, a small crater, about 10 kilometers across, is left in the center of the worst wildfires the planet has seen in millennia, spreading throughout South America, burning down forests and cities alike. And now, the unpleasant part begins. Extremely radioactive material will kill living things very quickly, and a large area several kilometers around the crater is now uninhabitable, as is everywhere for hundreds of kilometers downwind. Much of the fallout is carried high into the atmosphere by the mushroom cloud and carried
So
around
it
the
fucks
planet.
all of South America right away,
The
pretty
amount
much.
of radioactive material in the environment doubles worldwide, which still isn't civilization ending, but we may see more cancer for a while. A portion of the particles will float to the edge of space for years and cause a nuclear winter that could lower global temperatures by a few degrees for a few years. This explosion was pretty bad if you're in South America and especially Brazil. The Amazon rainforest is pretty much history, which is not great, but human life will go on. Okay, but what if we explode more nuclear weapons? Let's suppose humanity decided to mine every bit of uranium on Earth and build as many nuclear bombs as possible. At current usage, it's estimated that there are around 35 million tons of uranium in Earth's crust, enough to power human civilization for over 2,000 years, or to build millions of nuclear warheads. For the sake of argument, let's say we create a pile with the yield of 10 billion Hiroshima bombs, which makes up a cube 3 kilometers high that contains roughly the energy of the asteroid impact that ended the age of the dinosaurs 65 million years ago, except it's also nuclear. 3, 2, 1.
It's too many bombs.
Our pile explodes in a fireball stretching so high into the sky that it's visible from half of South America, with so much power that the ground just splashes like water, forming a crater 100 kilometers across. Bedrock on the scale of whole mountain ranges is vaporized in an instant, while thousands of tons of material is catapulted away with such speed that it's ejected into space. Some leaves Earth forever, while most of it comes raining down as hot, burning debris that heats up the atmosphere to oven-like temperatures, killing most big animals and causing firestorms all over the world. The Earth's crust rings like a bell, struck by global earthquakes stronger than anything in recorded history, decimating cities around the world, while hurricane-force winds flatten every single tree in South America and wildfires consume the continent. The abundance of hydrocarbons in the Amazon burned to form ash are cast into the atmosphere, darting the sky and keeping sunlight from reaching the surface, dropping temperatures to near freezing worldwide. The ensuing global winter may last for decades and results in the extinction of every large animal species, humans included.
Uh-oh.
We could also mention that every corner of the planet is covered with radioactive
It's
fallout,
like this is like
but
a
at this point,
supervillain shit.
it doesn't matter that much anymore. This is humanity's extinction event. The astronauts aboard the International Space Station get to enjoy a great view for a while, but it's not unlikely that the spray of rocks blast into orbit will destroy the station. Those lucky enough to be in bunkers or in submarines deep below the ocean surface may survive the longest before they exhaust their food supplies and have to venture out for more. They'll find the world a charred, freezing, radioactive wasteland. The planet itself doesn't care at all. After just a few million years, the wounds of the explosions have healed and life is thriving, arguably even more so than when humans were around. If intelligent life
We get
emerges
big
again,
fucked up rabbits,
it might
I
be able
guess.
to work out what happened. When they study geology, they'll find a bizarre and very thin layer of rock covering the entire world, enriched in radioactive elements like uranium and the other nasty things it decays to, mixed with rare earth metals and plastics that humans used. They would probably be very, very confused. Videos like this one take well over 1,200 hours to finish. Over the years, we put more and more effort into research, conversations with experts, illustration and animation, sound design and fact-checking. For this video, we put a lot of extra work into our sources document. You can read how we got to the information in the video, what our experts thought about it, where they disagreed with each other. We can take the time to do this because of you, our viewers.
What else? This guy's channel's really, really cool. Great filter. That was the one some people were asking for. Great filter. Okay.
Imagine NASA announced today that they found aliens. Bacteria on Mars, weird alien fish in the oceans of Europa, and also ancient alien ruins on Titan. Wouldn't that be great? Well, no. It would be horrible news. Devastating even. It could mean that the end of humanity is almost certain and that it might be coming soon. Why? Why would the most exciting discovery of our lifetime be bad?
Yeah, I remember Kyle and Harley
Let us
talking about
imagine
this.
the development of life from its inception to us today as a flight of stairs. The first step is dead chemistry that needs to assemble itself into self-replicating patterns, stable and resilient, but also able to change and evolve. The second step is for our early life to become more complex, able to build more complicated structures, and use the available energy much more efficiently. On the next step, these cells combine to become multicellular beings, enabling unbelievable variety and further complexity. The step above sees the species evolve big brains, enabling the use of tools, culture, and shared knowledge, which creates even higher complexity. The species can now become the dominant life form on its planet and change it according to its needs. First, shy attempts to leave its planet are happening. This is where we are now. It's in the nature of life as we know it to reach out, to cover every niche it can. And since planets have a limited carrying capacity and lifespan, if a species wants to survive, it will look for more places to spread to. So the steps above the current ones seem logical. Colonize your own solar system, then spread further to reach other stars. To the possible final step, becoming a galaxy-wide civilization. It's very likely that this is a universal principle for civilizations, no matter where they're from. If a species is competitive and driven enough to take control over its planet, they'll probably not stop there. We know that there are up to 500 billion planets in the Milky Way, at least 10 billion Earth-like planets. Many have been around billions of years longer than Earth. But we're observing 0 galactic civilizations. We should be able to see something, but there's nothing. Space seems to be empty and dead. This means something is preventing living things from climbing the staircase beyond the step we're on right now. Something that makes becoming a galactic civilization extremely hard, maybe impossible. This is the Great Filter, a challenge or danger so hard.
What are we? Aren't we like a level 0 civilization? Because we're still stuck using oil and shit? Isn't that a 0.7 out of 1 civilization? Yeah, Queb did talk about this, you're right. VR porn? I don't know what level of civilization that puts us on.
Hard to overcome that it eliminates almost every species that encounters it. There are 2 scenarios. One means we are incredibly special and lucky. The other one means we are doomed and practically already dead. It depends on where the filter is on our staircase. Behind or ahead of us. Scenario 1. The filter is behind us. We are the first. If the filter is behind us, that means that one of the steps we passed is almost impossible to take. Which step could it be? Is life itself extremely rare? It's very hard to make predictions about how likely it is for life to emerge from dead things. There is no consensus. Some scientists think it develops everywhere where the conditions are right. Others think that Earth might be the only living place in the universe. Another candidate
that can't be true.
Is the step of complex animal cells. A very specific thing happened on this step, and as far as we know, it happened exactly once. A primitive hunter cell swallowed another cell, but instead of devouring it, the 2 cells formed a union. The bigger cell provided shelter, took care of interacting with the environment and providing resources, while the smaller one used its new home and free stuff to focus on providing a lot of extra energy for its host. With the abundant energy, the host cell could grow more than before and build new and expensive things to improve itself, while the guest became the powerhouse of the cell. These cells make up every animal on the planet. Maybe there are billions of bacteria-covered planets in the Milky Way, but not a single one, apart from us, has achieved our level of complexity. Or intelligence. We humans feel very smart and sophisticated with our crossword puzzles and romantic novels, but a big brain is, first and foremost, a very expensive evolutionary investment. They are fragile. They don't help in a fistfight with a bear. They cost enormous amounts of energy. And despite them, it took modern humans 200,000 years to get from sharp sticks to civilization. Being smart does not mean you get to win automatically. Maybe intelligence is just not so great, and we're lucky that it worked out for us. Scenario 2. The filter is ahead of us. Plenty of others died already.
First Take Joe, thank you so much.
The filter before us is orders of magnitude more dangerous than anything we encountered so far. Even if a major disaster killed most of us or threw us
mitochondria is the powerhouse of the cell in chat.
And if we can recover, even if it takes 1,000,000 years, then it's not a great filter, but just a roadblock to an eventual galactic civilization. On universal timescales, even millions of years are just the blink of an eye. If a great filter really lies before us, it has to be so dangerous, so purely devastating and powerful that it has destroyed
yes, you did, Stinger.
if not all advanced civilizations in our galaxy over billions of years. A really daunting and depressing hypothesis is that once a species takes control over its planet, it's already on the path to self-destruction. Technology is a good way to achieve that. It needs to be something that's so obvious that virtually everybody discovers it, and so dangerous that its discovery leads almost universally to an existential disaster. A large-scale nuclear war. Nanotechnology that gets out of control. Genetic engineering of the perfect superbug. An experiment that lights the whole atmosphere on fire. It might be a super-intelligent AI that accidentally or purposely destroys its creators.
So basically there's a lot of ways for shit to go wrong.
Even see coming right now. Or it's way simpler. Species competitive enough to take over their planet necessarily destroy it while competing with each other for resources. Maybe there are runaway chain reactions in every ecosystem that once set in motion are not fixable. And so once a civilization is powerful enough to change the composition of its atmosphere, they make their planet uninhabitable 100% of the time. Let's hope that that's not the case. If the filter is ahead of us, our odds are really bad. What we can hope for. This is why finding life beyond Earth would be horrible. The more common life is in the universe, and the more advanced and complex it is, the more likely it becomes that a filter is in front of us. Bacteria would be bad, small animals would be worse, intelligent life would be alarming. Ruins of ancient alien civilizations would be horrible. The best case scenario for us right now is that Mars is sterile, that Europa's oceans are devoid of life, and the vast arms of the Milky Way harbor only empty oceans hugging dead continents. That there are billions of empty planets waiting to be discovered and to be filled up with life. Billions of new homes waiting for us to finally arrive. How likely is it that we'll find life outside of Earth that is similar to us? Well, that depends on how many planets there are out there in their star's Goldilocks zone.
I know, I got it.
Star where water can be liquid. Because stars come in all sizes and configurations, this zone is different for every star system and requires a little bit of physics to figure out. If that sounds like fun to you, this quiz from Brilliant helps to break down the maths for exactly how this is calculated. Brilliant is a problem-solving website that teaches you to think like a scientist by guiding you through problems. They take concepts like these, break them up into bite-sized bits, present clear thinking in...
Yeah, that part was an ad. Hey, Vsauce, Michael here. Vsauce, Michael here. Oh, take the quiz. I already took the, well, I'm not taking this quiz. I'll fail. But the people asking if I passed the autism tests, yes. I passed all 3 of them. Don't pay no heed to the people who will say that's not true. They're missing, that's all fake news. It's fake news. To the brim, fake news. It wasn't 25% autistic. It was not. I didn't hit the threshold. You can't add it up. That's cheating. If I fail 3 tests with a 30% each, do I get to say I got an A- actually? No. I don't. I don't get to say that.